So I have a homework question. We're looking at the log 5x minus 1 plus the log of x plus 2 is equal to 1. And this is from chapter 13.6. So that addition, first of all, when we put logs together, these arguments get multiplied together. So it'd be log of 5x minus 1 times x plus 2 is equal to 1. So I have to FOIL that out. 5x times x gives me 5x squared. 5x times 2 is 10x. Negative 1 times x is a negative 1x. So 10x minus 1x gives me 9x. And negative 1 times 2 gives me a negative 2. So I have 5x squared plus 9x minus 2 is equal to 1. So because this log, there's nothing there, it's called the common log. So the base is 10. So we're going to rewrite this logarithmic as an exponential. So it's going to be 10 to the first power is equal to 5x squared plus 9x minus 2. So it's a quadratic. I need to have it set equal to 0. And I get 0 equals 5x squared plus 9x minus 12. So my next step is, this doesn't look like it's going to be factorable, so I'm going to use the quadratic formula. My A is 5, my B is 9, and my C is negative 12. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just going to plug my a's, b's, and c's in. So negative 9 plus or minus the square root of 9 squared, which is 81, minus 4 times 5 times negative 12, all over 2 times 5. So I'm plugging in my calculator, 81 minus 4 times 5 times negative 12. And inside of the square root, I got 321. So I have negative 9 plus or minus the square root of 321 over 10. So there's two different answers here. Negative 9 plus the square root of 321 over 10. And negative 9 minus the square root of 321 over 10. And you're going to plug those in your calculator separately. So first I'm going to do negative 9. And then I'm adding, I should put it up here, negative 9 plus the square root of 321. I got that answer, and then divide it by 10. So this gives me, this wanted it rounded to the nearest hundredth, so I get 0.89. And then I'm going to do negative 9 minus the square root of 321. And then divide that by 10. And I get negative 2.69. So if I go back to the original problem, that negative is not going to work because I'll wind up having a negative inside of the logarithm argument, and I can't have that. So that negative 2.69 I have to throw out. And my solution is x is approximately, because we've gotten a decimal when we rounded it off, it's approximately 0.89.